Hey everybody, Mr. Steve back, and we're gonna learn how to isolate mesh. We're gonna use attribute text data in the viewer node to identify where we want certain things to happen and where we want things to not happen on the mesh. Hey everybody, I'm really glad you're here. I've got a basic torus and I'm going to throw in geometry nodes. Now, in order to visualize this, which is one of the best things you can do in geometry nodes, I'm gonna throw in a delete geometry. We're going to be working with the index, and we're going to want a math node, and we're going to want to use modulo math. So we're going to be looking for the truncated modulo, which requires obviously the input. We'll go with the index and a value of 2. And why are we using 2? Well, the index and the modulo math is looking for a remainder, and what we do is we take the index of, say, 0, and we divide it by 2, and then of course we would get 0. And if I pull out my handy dandy calculator here and I put in 1 divided by 2, we get 2. There's no actual remainder, there's no 0 point anything, so then that's going to be what that is. And if I put in 3 divided by 2, 1.5, so that gives me a remainder, and that will switch that one to 1. So if it doesn't have a remainder, it's 0. If it has a remainder, it's going to be 1. And then so on and so forth. It's going to have this perfect repeating 0, 1, 0, 1. And that is something we can absolutely use. Now, what you're going to want to do is say, what am I using here? And it's looking for mesh only for this. So if you have a curve, you have to convert it to mesh and do a profile. So just looking for points, edges, faces, splines, instances, and layers. So we'll go with faces here, and you see we are actually deleting every single other face. This is really cool. So let's take a look at this. If we plug in the index here, what we'll notice is that we have the index going, and I think this may be a little easier to see if I do a greater than and then plug in the index. So anything greater than 0 is getting deleted, and obviously this is kind of how this will work. You can get a general idea. Now if I remove that, let's unplug that, plug the modulo back in, then we're getting this. Now let's get the truncated math right here and put it in, and voila, we have our 0, 1, 0, 1 repeating pattern. And this is going to be something that is extremely usable in geometry nodes. So let's go ahead and do a setup for this. I'd like to go ahead and get a join geometry in here. I'll unhide that. Cool fact, if you ever have a node selected, you can just press O to connect it to the output if you have the node wrangler enabled. So now what I want to do is I want to just extrude only these faces that we've isolated and deleted everything else. Bring this down just a touch, turn off the individual. I don't really need all of that. Now, pulling off of the main mesh here, I'm going to want to plug in a mesh to points, not top, to points. And once I have that node, I want to plug in an instance on points. Now this is going to be deleted as well, so we could just duplicate this, but we're going to need to switch this from face to instance, and we can go ahead and plug that in. Now what we want to do is put something here that we can instance, and let's clean this up a little bit. Let's get our join geometry here, and we can plug this in. I want my original geo to be in here as well, so this can be something that possibly I just clean up and pull down here so it's not in the way. So now we've got our extruded mesh. We're deleting based on the modulo math with a division of 2, because technically not division, it's a remainder. And then we've got our instance on points, mesh to points, and we can do this on faces. So you have an option. You can instance these points on vertices, faces, or corners. And I think corners might be new. I don't remember seeing that one in the past, but here we go. So I've been spending a lot of time in the Serpents add-on creator in Python, so now I'm back in geometry nodes, which is a lot of fun. Now for the instances, I'm going to use cubes. Go ahead and plug those in, and I'm going to want my truncated modulo math to dictate where these are deleted. And I want to delete them anywhere there is an extrusion. I want the extrusion to be exclusive and not have anything. So as you can see, it is unfortunately right in the extrusion right now, and I don't want that. And one thing we can do is we can go ahead and let's output one of these values here. And for the offset scale, we can leave that the same name. I don't see anything else I care too much about exporting to the properties panel just yet. Okay, so this looks good. And what I want to do is just add in another math node right here in line. And we can go ahead and take this math node and we're going to switch this to multiply add. We're going to kind of need to split hairs here to get this to work. I want the multiplier to be in a negative value and I want the addend to be 0.05 instead. So I'm just going to drag this into the negative a little bit. And as you can see, right around 0.08 for this mesh, I no longer have any of my instances showing up there. So that's good. And as I do my extrusion, you can see those instances are gone from there. And we can go ahead and do a small amount of cleanup here. Shift P for Blender 4.5 and up will bring the framing in, and I can go to node, add color, something like that. And then we can go ahead and add another one here. Shift P works good. And now what we get is something that's a little bit cleaner. I always like a little bit of housekeeping, keeps things logical, which is nice. And I think Alt P will pop that out of there, and then we can kind of straighten things up. So now that we've got that done, what we want to do is, I guess we could just go ahead and do an align here. And I want to align rotation to vector. And when I plug this into the rotation, it's not being fed by anything, but you could change all of this. Instead of doing that, what I really want to do is just, I want to capture an attribute here before anything else is changed or deleted. I want to get all of these, I want to get the normals out of this before that happens. So we're going to go ahead and plug in the normals. And then what we can do is we can output this into the vector, and that will give us an alignment, which looks pretty good. And then we can rotate the rotation, which is an interesting node in and of itself, and you can kind of play around with the alignment however you want that to look, and then maybe change this so it lines up a little bit better. Okay, so now you've got that, and if we go into wireframe, you can see we are not instancing anymore there. So this truncated modulo is a really powerful node and allows you to do an awful lot. So what we'll end up with, and one last thought, I was able to come up with some rotation logic to align all of these with a few very specific nodes. The corner of face, vertex of corner, the edge of vertex, and then evaluating the index. Some nodes have changed since the last time I tried to do this. The evaluate on domain, I'm trying to read the edges. So the edge index feeds this. The position data will feed obviously the value. And then the evaluate domain, I'm looking for vector and face, and then I want to subtract the results of that from the domain. And then I am splitting the edges so that I can isolate the actual individual faces to line this up. And then I'm sampling the nearest by face, and then we're sampling the index. And all of this geometry is just basically coming out of the main geo. So this is where my capture attributes are. And then sampling the index on vector and face. And then I'm using a depreciated node here because I don't know another way to do it at the moment. And I'm using the align Euler to vector. And so my sample index results, which I'll just show you guys, so you can maybe pause the video and you can see what I did. And I suppose we could just clean up a little bit of this so it makes a little bit more sense. I've just got the normals and the index. Don't worry about that. Just some troubleshooting. And what I have here is just the main geometry, as you can kind of see. Now with that, that's plugged into the align Euler vector, which is depreciated and going away. And this is feeding the rotation for a second one. I'm pulling the normal out of the capture attribute here, and then the normal is feeding the vector. And then you can just set this up on the Z wherever it makes sense to you and plug that into the rotation for the instance node. And then you will get a nice, beautiful alignment like that. And that's it, guys. I appreciate you. And I'll see you guys in the next one.